Ajax getting an A.
I like Raphael. That's my favorite one.
Yeah, Raphael's red with the knives.
Yep, 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 the size.
And Michelangelo's black one with the nunchucks.
Yep. All right, well, so somebody here knows all of them. So we have Leonardo, blue katana blades, Donatello, purple bow staff, Raphael, red size, the little forks with the extra long thing in the middle. Michelangelo is orange with the nunchucks. And who's the smart one? Donatello. So he's our favorite.
Purple one.
Yep, purple one. Okie dokie. Let me, oh, hold on. I gotta get our AV system started up here. I am unprepared. Find that Professor Locklear is also a Teenage Mutant Ninja Turtle fan. So you want to earn brownie points in his classes. Drop a little Teenage Mutant Ninja Turtle trivia. Okay. Okay, so last class we were, everybody can see my screen now, right? I think I shared it online and also shared it here in class. Everybody's good. And recording has started, so we're okay. All right, so last class we talked about kind of a little pitfall you might run into where if you were trying to take something to the power, all these things that I keep mentioning, they're somewhere here in the slides anyways, but I just kind of mention them out loud as they pop into my head or they come up, so you'll see it reviewed in a later slide anyways. But last time we looked at something along these lines where we had like a 7 to the, what we might think is the third power, like that, when this is actually the bitwise exclusive OR operator, which means that we would apply the Boolean stuff at the per bit basis on the binary version of 7, exclusive OR with the binary version of 3. So we run that, we get a 3 out of there. Actually, we got a, or here I ran, oh, I didn't print that. Well, here, we just do it down here. So 7 exclusive OR 3 will give me a 4. So if you would write out the 3-bit version of 7, which is 111, and the 3-bit version of 3, which is 011, and then you took each of those individual bits and exclusive OR'd them together, you would get the binary version of the decimal number 4. That's where that comes from. If you actually want to get a value to a power, you would use 2 asterisks next to each other. So 7 to the third power is written that way in Python. All right, so just a trivia type thing for you. I will not test you over bitwise operations or anything like that in here. That's in the 325 class. You'll deal with that stuff. This is more of, if you get a weird answer and you don't know why, that's what's going on. Okay, and we mentioned that last class. So if you need to review that, go back and look at the videos from last class. Now we Let me kick it forward a little bit. For today, you had a paper, right? Okay, where you were kind of comparing and contrasting Python to where it fits in the world of programming languages. All right, so let's kind of fill in a little bit of a picture here, more for, let's call it somewhat trivia type stuff. I'm actually going to put C here at the very top. I'll have these branch off here, and then I'm going to create some other languages over here. So I'm going to start off with a language called Perl. And this is in no way complete because all these languages are interpreted languages. And we've already spoken in here that interpreted languages are kind of a dime a dozen, much easier to create. So you might imagine there's lots and lots and lots of them. So I'm going to kind of hit the, the highlights of the ones that have been popular over the years. And I'll actually go ahead and label these two columns. I call these the native languages. These are all compiled. This happens to be that they are all compiled languages because they're used for writing software that runs natively on various operating systems, as opposed to running it through an interpreter that maybe makes the life of a programmer easier. And the catch-all for this guy over here is we're going to call these guys the web languages. Even though Perl predates the internet, so it was originally used for Unix system administrators to write scripts for, like, creating user accounts and doing system backups and that kind of stuff before the internet was a thing. So then once the internet kind of became a thing, and all of a sudden you had people wanting to have websites and being able to do authentication through things that we take for granted today, right? Every website you go to, there's you look for the login button, right? That was like, magic back then. It wasn't something that people were doing. But once the internet became popular enough where that started becoming something, they needed a language to sit behind the web pages to be able to process those authentications. When you put in your username and password, hit that submit button, those two pieces of information go somewhere, right? They're going to go across the internet to some computer program that's going to process them and determine, are you a validated user or not? All right, so they needed a programming language that would do that processing. So in the early days, what they did is they had to leverage a language that already existed. So Perl was kind of the go-to cool kid scripting language for Unix sysadmins who were, having to pivot their normal responsibilities to now also deliver the web. And I remember back in those days, they were all complaining, oh, this is this newfangled thing. It's not going to turn into anything. And then, it kind of did. But, they really were having to leverage the current tools that they had in order to accomplish this. So kind of jerry-rigging it or duct taping it, however you want to think about it. PHP was probably our first dedicated web language. Still an interpreted scripting language similar to Python in many ways, but it was built with the web in mind so that it had a whole bunch of internet-y things built in, connecting to databases, templates for showing things, in kind of a pretty HTML format, that kind of stuff. But I'll just keep going down a list here just to get them in here and then reveal something interesting. So let's go ahead and put, we'll put Ruby next to it, and you'll very rarely hear Ruby just used by itself. It's usually Ruby on Rails. Cool kids just call it Rails. I'll mention that as we blow past it. We'll throw Python in this list. And we'll throw Nodejs in this list. And this does omit plenty of languages. Let's just say that this hits the highlights. Now what I'm going to do is I'm going to float something over here on the side. called JavaScript. Leave it like that. Sometimes you just see it as JS. And I'll put some other things you may have heard of. Ajax. jQuery. Well, actually, let's throw a couple more in there. Angular. React. All right, so let's just go through this list here real quick, just from a history perspective. I'm not going to spend a whole lot of time on it. Perl, already kind of talked about that, predated the internet, was the go-to move for Unix system administrators. So it was the first tool they kind of used to, they also use C to accomplish this. But first tool they used to try to process websites. PHP, interpreted language, think of all these very similarly to Python in terms of where they fit in the world of languages. But PHP was specifically created to target the web programming problem, not that you couldn't use it for other things. Ruby on Rails was an interpreted language, and this on Rails part, Rails was a built-in web server. Because one of the problems as a PHP developer, and by the way, I'm not going to test you over this stuff. I'm more giving you kind of a background of where these languages fit. You know, this kind of goes with your paper you just wrote. Because as a computer scientist, you want to always use the right tool for the job, and somewhere, you know, you want to have somewhere a foundation for kind of what are some of the different choices that were taken, when is something maybe the right tool for the job, you know, that type of thing. So I'm kind of giving you an idea of how things sort of evolved and that kind of stuff. So if you were an early web developer and you were writing in PHP, one problem you would have had is that you kind of had to be a programmer as well as like an IT professional. And those two things aren't necessarily always the same. So for instance, my wife has been a computer programmer for 20 plus years professionally now. And she doesn't know anything about servers and, you know, she can't set up her, well, I mean, if she reads the instructions long enough, she could set up her Wi-Fi router at home, but that side of it isn't her interest, right? So I was a hobbyist. I played with all the computer equipment and networking stuff. So, you know, I learned all that stuff kind of by accident. But her, with a degree in computer science, she's completely a computer programmer. Doesn't have that IT side of things, launching a web server, giving your, you know, access to file transfer protocol, FTP, to send your files from your local computer up to the web server so that somebody else across the world can go and view your stuff online. All these things go together to ultimately give, you know, that full product. Now today, if you're a web programmer, you want to have a way of getting your stuff out there, you can go to like GoDaddy.com or something like that, and, you know, for $5 have a monthly web hosting account that you could put all your files, you could see it anywhere in the world. Otherwise, when you're writing web stuff, you're sitting here local on your computer, and it might look beautiful here, but nobody else in the world can see it. Because it's just locally on your machine. So the idea is if you were a PHP developer and ultimately your job was to create web pages that the rest of the world could see, you then had to have the ability of bringing up a web server, making sure it had the PHP module in it. Let me just quickly kind of show you that, you know, here's how the internet works. We have our client computer, often called the web browser. So that's Chrome, Firefox, whatever. And over here, we have the server. So this might be something like Apache, or kick it down the line, IIS, Internet Information Server. So this is This is Microsoft, this is everybody else. So if you're running your web servers using Linux, you're probably running Apache. If you're running it using a Windows server, you're running Internet Information Server. But this is a computer program that's running on an operating system whose job it is to serve web pages. Go ahead. It might be, but it's not a popular one. Yeah, not an enterprise one at least. And maybe what you're talking about goes hand in hand with something I was mentioning here is as a PHP developer, you kind of had to have the background yourself. And initially you had to bring up like a local web server to help you do your software development on your machine and actually have it process your PHP code so you can see whether it was working or not. So there's been plenty of tools that have been created to kind of make that problem easier. But in the early days, you had to bring up a whole environment. Okay, so in any case, this guy is a computer program. This guy is a computer program, right? You download Chrome, installed on your computer, you launch it, and now that's your window into the internet. It's a computer program that happens to speak a certain language, all right? And this is kind of going to go hand in hand with what we're going to be talking about here in a few minutes. So even though a lot of this is trivia information that I'm not going to be testing you in here over, it's supporting information that creates a foundation for things that I will be testing you over. All right, so it's not useless. We're not just burning time here. But so your web browser and this web server, which is a computer program that runs on a Linux server or runs on a Windows server, they speak a language with each other. Anybody know what the language that a web browser or a web server speak? Nope, but HTML is involved in this. And sometimes if you want to have the more complex version of HTTP, yeah. The more complex version of a language is a protocol. Computers speak protocols because it sounds more difficult, right? It's a language. We're speaking English. You might pick another language, speak Spanish, speak French, whatever. A web browser and a web server, they speak a language called HTTP. Stands for Hypertext Transport Protocol. It's a computer networking concept. You'll, when you have the 440 class, you'll talk about networking stuff and you'll cover this stuff in there. But, you know, these two computer programs need to talk to each other somehow. The language they're going to use is HTTP. All right. And that is a domain-specific language specifically for allowing a web browser to request web pages from a web server. And this web server might have to do some extra stuff. So for instance, on this web server, you might install the PHP module. So that if the browser requests a blah.php file, the web server would go and look up that file, but notice that it was a PHP file, would have to run it through this interpreter. And the output of a PHP page is typically HTML. Because ultimately what a browser does is it knows how to display HTML, hypertext markup language, in pretty pictures and text on the screen. So underneath the hood, your web pages look like a whole bunch of gobbledygook. The web browser turns it into something interesting looking. All right, and ultimately the web server will spit back HTML, JavaScript, and CSS. All right. Now the CSS thing, that guy was a little bit late to the party. That's kind of making your web pages all look consistent across the, you know, if you want to change the background color, you can change it in one file and now all your pages have the new background color, kind of a convenience thing. But these first two are really the important ones for us to consider. These are two languages, but only one of them is a programming language. Remember, all programming languages give us facilities for memory, asking questions, repetition. HTML is something called a data representation language. It's a way for organizing data in such a way. I'll just create a slide for that real quick. So HTML is one of these. Maybe you've seen XML before. This is kind of a chicken or the egg type thing, because XML postdates HTML, but was inspired by the tag-based HTML language and was used to create XHTML, which is, let's call it perfect HTML. One issue you have modernly as a web developer is when you create a page, you have to test that page on all the different browsers. You got to test it on Chrome and Firefox and Safari and Edge now to see if they all look the same in all the different browsers. Now they should look very, very, very similar, but this goes back to the early days of the internet where those web browsers were kind of, you know, hodgepodge together, and they accepted non-conforming HTML. They allowed a web programmer to write HTML that didn't, that wasn't quite perfectly written for every opening tag. You didn't have a closing tag, stuff like that. And we're not going to talk about HTML here, but we're just telling you this at a high level. And actually, one of the main contributors to this was Microsoft itself. Microsoft had a program in the early days of the internet called Front Page that allowed you to kind of make web pages kind of like you were working on a Word document, and it would save it as HTML. But the HTML that outputted from Front Page was not very well formed HTML. So they had to make updates, things in the web browsers to make them more lenient to those pages to make them look reasonable. Well, what that's left us with today is it's left us with these web browsers that don't necessarily handle the same HTML the same way, because they've been through years and years and years of bug fixes and, you know, making one little change to make, you know, this certain site work, things like that. You now have them treating different things in a little bit different way. Most of our modern day web browsers actually have an XHTML mode you can turn on. But what you'll find is if you do that, probably 20% of the internet breaks for you. That's how many websites out there don't use conforming HTML. So more of like an interesting thing. So XML is a tool for creating data representation languages, and it was based on an early data representation language called HTML. Modernly, if you're using data representation languages, you use JSON, which actually stands for JavaScript Object Notation. And the punchline here is this is how the JavaScript programming language represents objects. So once we get to objects, I'll talk about that again. And actually, once we start talking about dictionaries in here, you're effectively looking at JSON. Because Python's whole list and dictionary syntax is basically JSON. That's what it is. Good.
React also a data representation language?
No, and we'll be getting to React here in a second. Okay, so punchline of this slide and this guy right here is to recognize that not every language is a programming language. That doesn't mean it's garbage. You know, HTML is very, very important. The whole internet is driven on top of that. But the point is, it's not a programming language, so it can't ask questions, it can't store variables, it can't do loops and functions and those types of things, which is why embedded inside of HTML, you have JavaScript, which is a programming language. So technically, if you're on a computer, you always have, well, let's call it a very, very high percentage of the time the computer has a web browser on it. You always have an interpreter available to you. If you know the JavaScript programming language, you can write a little program in a text editor, run it inside of the web browser, and have the output of your computer program. You can think of a web browser as kind of like the Python interpreter, because the web browser, among other things, is a JavaScript interpreter. It knows how to run JavaScript. All right. But in order for our pages, our web pages to be dynamic, we need them to be able to handle HTML as well as JavaScript. This is the dynamic part that allows you to, accomplish programming type stuff. Make sense? And just to kind of, let's finish out this slide, we would call this client side or front end. So if you're a front end developer, you're writing stuff for this side of the equation, what things look like on your web browser, validating web forms. So, you go to you're creating a new account on a website, and you have to fill in 5 or 6 different boxes. When you hit submit, before that gets sent over the internet, a local JavaScript program is checking all those boxes to make sure you filled out the right ones and gave it valid information and stuff like that before it tries to create your account on the other end. All right, that way we're not bogging down that web server with stuff that likely wouldn't work. If you didn't even put your password in, it's a waste of time to send it to the server, right? You have some required information that needs to be there. So JavaScript is used on the front end. If you're a front end developer, you're making stuff look pretty, organized well, things like that, but also you're doing a lot of form validation and things with JavaScript that completely resides inside the browser here. On the other hand, this is server side or backend programming. All right, so if you're ever looking at jobs or internships and they're talking about, probably today they would say backend. You're a backend developer, you're a front-end developer. That's which side of, first of all, that says we're looking for a web programmer, which doesn't mean wimpy programmer. It just means this is the kind of thing you're working with, is web technology. But if they say back end, they're looking for a certain thing. If they're saying front end, they're looking for probably more of a hybrid skill set, kind of a having an ability of doing some artist type stuff, design type stuff, as well as being able to program. Now, there's something I'll put here in the middle that does relate to this, but it actually probably started off meaning something else, but I think it kind of has morphed into meaning this. There's something called a full stack developer. So if you see something that says full stack developer, what this is effectively saying is you know how to live on both sides of this coin. You know how to do front end stuff, you know how to do back end stuff, but it adds one little caveat. There are various stacks in web programming, let's say. Well, it's across the board, but web programming is really where this phrase is used, where you have a collection of 3, 4, 5 technologies that all kind of go together seamlessly to create websites. So for instance, the popular stack, if you're going to be a PHP developer, is called the LAMP stack. That's one example. So there's some different stacks that you might use, whereas a full stack developer, they expect you to be very familiar with all the tools in that stack. And different tools in that stack of tools might lend themselves to front end or to back end type stuff. But the idea is that you're using a certain kind of database, you're using a certain front end technology, a certain back end technology, a certain technology to make those talk to each other. All those things kind of go together where it's like a full system that all just kind of work well together, okay? Not that you couldn't take a piece of these different stacks and make them still work with each other. They just aren't quite maybe written to be as seamless. You might have to work a little harder to get this guy talking to this guy. Not that it can't be done, but the stacks are kind of designed in terms of each other, okay? So when you see full stack developer, it probably means web developer, very used to working with a specific set of tools. But again, programming is the skill set, not the technologies themselves. So as long as you have a background in programming, you can become a full stack developer in any of these stacks with a little bit of training. They introduce you to the 3 or 4 different things, and you use them a couple times, you see how they interact with each other, and you're off to the races. Makes sense? But so this kind of gives you the I'm looking for an internship lingo, so you kind of know what places are going to be asking you for. But effectively, the way the internet works, or the way the web part of the internet works, is your browser requests a web page, the server goes in, gets that web page from its data store somewhere. It might pre-process it if it's a certain kind of web page. Ultimately, it's going to send back to the browser HTML, JavaScript, and CSS, because that's what this browser knows how to process and ultimately spit on the screen. That's the circle of life. We should have the music playing. For a website, okay? So when we go back to this guy here, all of these languages, well, all of those live firmly in this world. But I'm going to kind of talk you through these a little bit. But let's start right here. How many of you have heard of JavaScript before? Not that you've written in it, not just, it's been something you've heard. All right. Now, as I already mentioned here, this is kind of the language that web browsers know how to run. Okay. How many of you ever heard of a technology called Ajax? Okay, 1.5 people. jQuery? Angular? React? So what's funny is, and we see this, well, I mean, one thing you've already seen in technology just by being alive in today's world is they like to come out with products whenever there's a new upgraded something or other, they try to attach a cool name to it, right? Even though it's the same technology as 3 years ago, with just a little tiny upgrade or something, a little change. They say, this year's processor is 40% faster than last year's. I think I mentioned something about this, where it might be one of those little magic tricks that's more efficient. And then they give it a fancy name like hyper threading or something like that. And we just know that's awesome, right? so totally, I got to sell my computer. I got to spend $3 grand on a new one because I need that hyper threading, right? So there's a branding aspect to our world, right? And the same thing happens with programming languages. So all these sound, I mean, maybe they start sounding cooler more recently, but what's interesting is that, you have all of these different technologies, and these are just like kind of the popular ones. There's all sorts of other ones in here, but these come out every single year. There's, Ajax was a big deal, and I'll talk about what it did here in a few minutes. jQuery, another big deal. Angular, React, all of these are not actually standalone technologies. These are all special libraries written in JavaScript. So they're all leveraging this old programming language. In fact, if I go back here for a second, how many of you have ever heard of something called a Restful API, or just a REST API? So if you're ever looking at, again, jobs or something like that, dealing with creating an API. APIs are effectively languages for, like if I want to bring Yelp into my website, I might want to tie into Yelp's API so I can pull in Yelp's data. Somebody searches for McDonald's, I can go and look up reviews for the most local McDonald's and stuff, because Yelp has all that data, right? I don't want to have to go and create that data myself. It already exists somewhere. So an API lets us use other people's data sources, other people's technology, and bring it into our sites. And that's only if Yelp chooses to have an API for doing that, which they do. Facebook has the same thing, whatever. Okay. But what's interesting is over the history of APIs, which we have a whole class on APIs you'll take later on, but over the history of APIs, we had all these non-standard ways of accomplishing this, where you might have 5 different APIs in front of you, and the way you talk to this guy was different than the way you talk to this guy, was different than the way you talk to this guy, and so on and so forth. Well, over the years, we finally moved towards a standard. RESTful or REST APIs are one of the standards, and they operate off of something called CRUD. Just seems like made up stuff. These create these mean something. Just don't worry about that for right now. But the punchline of this is our modern way. Any API today is going to be a REST-based API. And it's built on top of four functions. So we have put, post, get, and delete. So the premise is this, that anything you might ever want to request of an API can be done in terms of these four things. So typically put means I want to update something there. Post means I'm going to put something new on the site. Get means I'm retrieving something. Delete means I'm getting rid of something. You can do everything in terms of those four things. But now the funny thing is that all of these things, came from the HTTP protocol, Hypertext Transport Protocol, which has been around since the internet started. Definitely a good technology because it's been time tested, right? And actually, when you're dealing with web stuff, you really only use posts and gets for processing web forms. These other two guys were basically not really being used. But then they said, hey, wait, we already have this protocol. We already have a way of talking between two endpoints called HTTP. Let's package that up and say all of our APIs now speak that language. So all these modern APIs today are speaking the same language as the web was day one of the internet. And that's after going through all these different pivots, looking at other, trying to do other standards, making up things, stuff like that. We had something in the middle called SOAP APIs, which tried to create a standard. And ultimately, we landed on a technology that's been around since the beginning. All right, but I mean, this kind of RESTful APIs, REST API, I mean, that just sounds expensive or techie. Sounds something. Way cooler than like, oh yeah, we're just going to use the old web protocol. HTTP doesn't sell, right? Something along those lines. So anyways, Ajax was a specialty library built using JavaScript. And Ajax solved a very specific problem for us. How many of you watch sports of some kind on the web? You keep up with scores of some event or something like that. Okay. Now, when you go to a web page and it has the let's say this weekend we have the Packers game, right? You don't want to have to keep hitting refresh constantly to get the updated version of the score. Well, in the early days of the internet, you would have had to. Ajax fixed that. Ajax said, we'll have this one little part of the page, and this part of the page is living, and it will, behind the scenes, go and hit the network and bring back and update its content with the latest score. Make sense? And that's something we take for granted today, right? Okay, well, what did, but the early version of this, Ajax was kind of the first way of doing this, was a little bit clunky. It's kind of like, okay, we're going to duct tape this and just find a way to make it work. Somebody sat down with JavaScript and said, okay, this is the tools I have available to me. I'm going to just slop this together. And we're going to have an answer. Okay. What was jQuery? jQuery was the better version of that. It allowed you, there's this thing in JavaScript called the document object that has a very specific format. And jQuery lets you walk along that format in a very convenient way to get to the part of the web page that you want to update. So call it Ajax Plus, something like that. But also a JavaScript library. Nothing special, not a new technology in terms of its underlying thing, just some smart people sat down with JavaScript and wrote a library. A lot of times, they don't call them libraries, they call them, these are JavaScript frameworks. So it makes you probably get an extra $10,000, $15,000 in your salary if you are an expert in a framework. Sounds better. I was at this cooking class I'm a golfer, so at my country club, there's a cooking class like 3 weeks ago, I think it was. And the chef was up there and he was teaching us how to cook this shrimp and grits thing. And he said, you know, he talked to us about polenta. Have you ever heard of a dish called polenta? So I think it's a Spanish dish, but it's effectively grits. He said, what's the difference between grits and polenta? He says, I can get $32 for polenta. So something along those lines. But the ingredients are the same. It just sounds fancier and, you know, whatever. All right, so jQuery was the upgraded version of Ajax. Angular. Now, so let's pause this for a second. And I want to jump over to this side. So Ruby on Rails solved the problem of the PHP developer where now they don't have to go out and create their own environment. Remember I mentioned that they don't have to be an IT specialist. Rails is their web server, comes with it. So Ruby on Rails, or if I'm a Rails developer, means you have this thing you install and it's all self-contained. It has all the stuff you need in one little pod. You do have to play by the Rails rules, which specifies this is how you do this kind of thing. This is how you do this kind of thing. So you could almost view this as its own integrated stack, the Ruby on Rails stack, because it already has, this is the way you store stuff. So you don't get a choice of an external database. You're using our database, this kind of thing. But it just allows you to install one thing and now you're a developer. Go to town. Python, general purpose language, but now has been applied heavily to web through one of the stacks. Now, Node.js, this became kind of an interesting thing. So if we come back to this slide here, the difference between a front-end developer and a back-end developer. So if you're a front-end developer, that means your whole job or a very large percentage of your job, hold on a second. Just noticed that my battery was basically dumping down because I forgot to plug that in. We're good. If you're a front-end developer, your whole world, or a large percentage of it, revolves around the web browser, which means that you are very, very, very heavily operating in a language called JavaScript. Now, if you talk to, quote, real computer scientists, they will often look at front-end developers as being lesser. I mentioned earlier that a front-end developer is kind of a hybrid type position, where you're kind of an artist who can also program. That's a fairly common thing. Now, I'd look at that and say that's kind of a superpower. Because one thing you run into, I mean, I've been teaching computer programmers for a couple of minutes. This is my 21st year of teaching software development. And it's somewhat uncommon for computer programmers to also be artistic. You know, they're not very good at making things look good. They can make things work. Well, we kind of rely on somebody else to put the nice facade on it, right? You know, so a lot of times when you have somebody who has both of those skill sets, that's a strength. Now, having said that, if you're a front-end developer, and maybe a lot of times these folks start off as designers, and then they learn how to program. Because they learn how to program in terms of a technology rather than learning how to program from the ground up, they might have somewhat of a limited framework for how to program because they've learned how to leverage a specific tool to solve very web-specific types of problems. That doesn't mean they're incapable of learning more. That just means that they're ignorant of some of those other things at the moment. All right, but these front-end developers it might be fair to say that they're generally less experienced programmers. They're used to using JavaScript as their programming language. Okay, now I've advertised in here that language does not matter. Once you know how to program, you can pivot to another language pretty easily. But imagine if you're a front-end developer and the way you learned how to program was maybe a little bit non-traditional. You kind of like learn trial by fire. You were thrown into the deep end and say, okay, you need to learn how to swim now because this web page needs to look good and it needs to be able to send these 3 or 4 things. So I mean, the stuff you do as a front-end developer, you're not making video games as a front-end developer, as a web developer. So you might have a fairly weak programming skill set. So learning another programming language to dabble on the back end, let's say, might be intimidating for a subset of front-end developers. With that in mind, we have a language, Nodejs, which is actually a back-end language, server-side language. In fact, Nodejs is really, really popular for creating, where's my, RESTful APIs. So in our API class, when we write RESTful APIs, we do that using Nodejs. Nodejs allows us to create our own RESTful APIs, but that is a server-side technology over here. But notice by the .js part of this, what do you think JS stands for there? JavaScript. So now your back-end language, which might have been PHP or Python or Ruby, whatever before, is now JavaScript. Your front-end language is also JavaScript. So now taking somebody who is a front-end developer and allowing them to start dabbling on the back-end stuff, they can now start working with the same language they're already familiar with. Even though I've advertised that the language doesn't matter, from a productivity perspective in your job in real time, and you're not trying to learn how to become a generalistic programmer, maybe working with something that you're already familiar with has its benefits. Make sense? All right. So that's kind of where Node.js fits in this, this world here. Now, Angular and React. This is Google versus Facebook. Same technology, but from two different superpowers, let's say. So both of these are evolutions of JavaScript frameworks. And what they let you do is they let you handle both front end and back end real-time stuff, similar to what I talked about, Ajax and jQuery, updating databases in real time on the back end and that kind of stuff. So just the latest, greatest JavaScript framework that's out. And we have two of them that are kind of direct competitors. I'm significantly more familiar with Angular than React, but they both basically do the same thing. Okay, good.
What do you mind? We kind of messing around with React and Node.js at the same time. Is there any reason why those two work together like that?
Well, they wouldn't have to work. I mean, React and Node.js, they're both operating in JavaScript. So they're going to leverage a lot of the same stuff anyways. Node.js is typically used for backend. React is used for front end, but it's a
Our templates are made out of React. We're using Node.
yeah, your front end stuff is made of React and it talks to the Node.js backend. Yeah. But it's probably fair to say that if we were really drawing the picture, you would have HTML and JavaScript like here. Then you'd have your React template just to the right of that. Kind of a little layer that sits between that and the actual backend that maybe makes that translation between the front end and the back end a little bit more powerful, because React allows you to do some stuff you couldn't have done before on a web page. So because of with Angular and React, we have this new idea. Let's put it next to it here. Single page websites. So rather than having, you click a link, it takes you to a whole other page that loads and things like that. What React and Angular lets you do is it lets you redraw the current site, where, the top stays itself and then this stuff just flips over to something brand new, a whole new page loaded within the current page. I'm not sure if that's necessarily better or worse. Maybe it reduces load times a little bit. But I don't know, whatever. Once again, it's hyper threading. It's whatever the newest, latest, greatest technology is, and you decide what's if you're like buying a car, like what's really worth spending money on a new car. Like maybe going from no air conditioning to air conditioning, that might be worth it. It's like, okay, I want to have air conditioning. I live in Arizona. Gotta have air conditioning or you die. something like that. For me, it's self-driving. If a car self-drove completely today, it's worth every penny. Sit in the back seat, just let things schlep you around. It'd be great. Yeah, Teslas are reasonably close to that on the interstate. They keep touting like, oh, you know, self-driving in town, you know, by the end of the year, whatever. Yeah, we'll see. I mean, I hope, because I have my Cybertruck on order. I already have my Tesla Cybertruck pre-ordered. It just doesn't come out till 2022. Yeah.
Oh my God.
I put money down and everything. I have a Cybertruck. Everybody needs one of those. All right. So in any case, do we sort of see this connection between all these languages over here have a lot in common? They're more like our Python languages. They're interpreted. Most of them are general purpose. All of them are loosely typed because they also are interpreted, and those two kind of go hand in hand. But they're also kind of a dime a dozen. I'm only showing you a very tiny part of the web languages. Well, that's kind of a catch-all, the interpreted languages over here, but we tend to use them for web stuff. But these languages were built on top of our native languages over here. So for example, our PHP or our Ruby or our Python interpreter was likely written in like C++, the actual interpreter of it. Maybe it was C, maybe it was C++, maybe it was, you know, Java or C# if it was, well, C# if it was a Windows specific interpreter, Java if they wanted to have the interpreter available to a lot of different places. You've already seen, probably you can go on the web and just do a search for like online Python interpreter, and there's websites that allow you to write Python right inside the website. That's probably driven by Java. That's probably a Python interpreter written in Java, because that's very web-centric. Java programs can be embedded inside of web pages, but it's still a full Java program. But effectively what we're seeing is the landscape of computer programming languages that exists today, and kind of the types of jobs they're meant to solve. One of these languages isn't just innately better than another one. Make some sense? And hopefully you came to kind of a similar conclusion in writing your paper. Just saw there's all sorts of languages out there that solve all sorts of problems, but they kind of all are the same kind of thing, just have some extra little tools in them that allow you to solve certain problems maybe a little bit more easily. All right, so we've already started talking about variables and conditionals, so more in the coding stuff here. So, you know, we're going to be operating for this course in this sector right here. But we will do a little bit with APIs and also databases. So we'll be talking to some external tools as we get into this. So what we've already looked at over here is we've looked at creating variables, right? So there's the variable name equals Mike, age equals 22. We've looked into asking some questions related to them. Remember this colon here is at the end of all of our statements, and then we indent underneath those. So anything that belongs to this if statement is indented underneath that if statement. All right. Now let's look at probably, we haven't looked at loops yet, have we? All right, let's look at loops. We have looked at Boolean expressions. What's a Boolean expression? Any expression that boils down to a single value of true or false. Okay, so this Boolean expression we're using here, an if statement allows us to ask a single question and respond accordingly. Make sense? That's when we would ask a question. All right. Now, if we wanted to write a loop, so let's say that I'm going to have a variable named I, and I'll start that off at 0. And then I'll say while I is less than 10, print I I is equal to I plus 1. So you can think of this as sort of like an if statement, but the difference is that we get to ask this question here multiple times. So I start off, what's this line do? This creates a variable and sets it equal to 0. So I have a variable named I, and its starting value is 0. Then what this guy does is called a while loop. So this says, while this Boolean expression is true, do this stuff. The stuff that's indented under the while gets executed as long as this Boolean expression continues to be true. That make sense? So start off I is 0. I ask myself, is the current value of I, which is 0, I'm going to resolve that variable so I becomes a 0 for this particular pass through loop. Is 0 less than 10? That's a true statement. So what will I do? I will print out the current value of I. And what's the current value of I? 0. And then I'll update I to be 1 bigger than it used to be. So now I is 1. Spin back up. Is 1 less than 10? Yep. Print out 1. 1 becomes 2. Spin back up. Is 2 less than 10? Yep. Print out 2. 2 becomes 3. 3 less than 10. 4, 5, 6, 7, 8, 9. Is 9 less than 10? Yes. Print out 9. 9 becomes 10. Is 10 less than 10? It's not. So that's now a false. We skip past this while loop. I'll just put another print in here and we'll say print done. So notice that this print statement is not indented under the while, so it does not belong to the while. So it's this stuff right here that will repeat over and over and over again as long as this is true. So this will print out 0 to 9, and then once this thing finally fails, we'll print out a done. Here's our 0 to 9, and then a done. That makes sense? So going back to right here, this guy. All programming languages have facilities for memory, asking questions, and repetition. Memory is our variables. I is equal to 0. Asking questions is our conditionals, like an if statement or anything involving a Boolean expression. We're using a Boolean expression again right now, right? Repetition. This could be loops. It also could be functions, which we'll talk about probably next class. All right. So we've explored these languages in terms of these primitives that all programming languages are guaranteed to give us. Yeah.
So while is technically a loop and Boolean.
Well, it uses a Boolean expression. A while loop is a loop. It's something, it's a structure that says, I want to repeat the body of this while loop. So we would call this the body of the while loop. The stuff that's indented underneath the while loop would be the body of that while loop. We're going to keep repeating that as long as this Boolean expression remains true. So it uses a Boolean expression just like an if statement uses a Boolean expression. So this code now, I starts off at 0. Is I less than 10? It is, so we'll print out only happens once. And then we immediately jump down to the next line and we do our 0 to 9. So there's our only happens once, and then the while loop takes over. Both of these guys leverage Boolean expressions to ask our question. The difference is an if asks the question once. A loop, in this case we're looking at while loops, asks the questions over and over and over and over again until that question finally boils down to a false. And then we break out of the loop and move on with life. That make sense? So that's a while loop. Now, you might say, so in this case, I'm going through all the values between 0 and 9 just because. That's a fairly common type of thing you might do in programming, where you might want to do something some number of times, right? So a lot of times we have different kinds of loops available to us. This is actually a little bit cleaner in some other languages like Java, but we can make it work here. While loops usually lend themselves to the types of problems where we don't know how many times we're going to need to spin. So for instance, like the press any key to continue. We don't know when that key is going to be pressed, right? So has it been pressed? No. 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 We're going to keep doing this until some event occurs. That's the kind of problem that a while loop kind of natively lends itself to. But you see, we really simply applied it to counting problems here, right? No problem, okay? For loops, on the other hand, typically lend themselves to counting type problems. So I'm going to say for I in range 0 to 10, print I. And you're going to see this gives us a 0 to 9 displayed. Here's our 0 to 9. So let's break this down into its pieces. What does range do? Range gives us a collection of all the values between 0 and this value right here, -1, incrementing by 1. The default for range is incrementing by 1. You can modify that and have an increment or decrement differently, but the default step is by 1. So this says start at 0, go up to this value, but not including that value. That's an important thing to kind of remember, so that when you write your loops using range, you make sure you stop at the right number. If I want to go all the way up to 10, I would have to make that an 11. Then I would get all the way up to 10. And that's just how range works. Range will generate for me, this guy right here will generate for me a collection of all the values between this guy and this guy -1. Yeah. Correct. That's how the tool works. Yeah, you go to Home Depot, you buy something off the shelf, it says this is how it works. Starts at the first number including, goes to the second number not including. That's what it does. All right? Because that's what this dude does. This dude spits out that. Same output. That's what it creates for us, is a collection of all the values between 0 and 9 in this case. All right, that makes sense? All right, so range is a function that exists, and that's what it gives us. Now we have this other new word here called in. So this would be historically called a for each loop. So each time through this loop, I becomes the next value in this collection. So for I in 0 to 9, print out every one of those values for I. Stop there because I'm having problems counting. So we've gone far enough. So notice this, for I in 1, 3, 2, 4, this prints out 1, 3, 2, 4. So this collection over here to the right does not dictate that it's in ascending or descending order. I gave it a collection of 4 values here. in no particular order. And when I printed them out, it printed them out in that exact order that I provided them. The first time through, I was 1. Second time through, I was 3. Then I was 2. Then I was 4, because that's the order that these guys are in. If I flip the 2 and 3 around, it'll do 1, 2, 3, 4. Range, though, produces for us a list of things in order. That's what that tool does. Make sense? Go ahead.
So I had switched the 10 with the 0.
Yeah, you're gonna have problems there.
Yeah.
So if we do 10 with the 0, I'm saying for I in range from 10 to 0, step by 1. So it's going to go 10 to 11 to 12 to 13 to 14 to 15. We'll be waiting. Oh, it detects that it's less.
Yeah.
All right, so let me show you what this guy's actually doing. It's putting in a -1 there as the step. Although we would have to go to -1 to go down to it, to include the 0. There's our 0. So there's actually a third parameter here in range. So if you give the first value is higher than the second value here, the default is it'll count backwards. It'll count down from this number down to this number, not inclusive. So it follows the same rules, but if the second value is smaller than the first value, it will count backwards. Actually, it didn't count backwards. So it still generated the list. I want to try something here. Yeah, it generated the list 0 to 9. So it didn't matter which ones I put in here. It must have had an if statement inside of it that says, if this number is larger than this number, then give me the list between this number and this number. Otherwise, the other way.
Well, I guess because the range is the same, right? The range from
right, but the output, the question is what's the output of this tool? Yeah. So again, this isn't a programming thing. This is a how does this tool work thing. All right, so if I actually wanted to count backwards, I have to use the third parameter of this tool, actually a little switch on the tool. And I can say, I actually want you to go backwards. Instead of going up by 1, I want you to go down by 1. So this will give me the 10 down to a 1 because it's not including this guy. Does that make sense? All right, so important thing to focus on here is that this guy right here is a tool that generates a collection of values. That's what he does. The in statement is actually a Boolean operator. So I can say 3 in 1, 2, 3, and that's a true. 3 is in the collection of 1, 2, 3. 3 in 1, 2 is false. It's not in there. So in is actually a Boolean operator that gives us a value of true or false. Returns true when something is in a collection, false otherwise. So as long as I still have something in my collection left to have I be a placeholder for, I'll make I the next thing in the collection and I can do whatever I want with it. I don't have to just print it out. I can multiply it by 2 if I want, whatever I want to do. Make some sense? All right, so those are a couple of loops for us to kind of practice with. Now, for your homework assignment, get down here to the end. Homework assignment is dealing with variables, so get you some practice. All right, so We've already written in class this hello world thing. We all have a working interpreter, so this isn't our assignment. Our assignment is going to be this guy. Write a program that stores the number of years old you are in a variable. So you're going to create one variable that is how many years old you are. 18, 19, 20, 21, whatever it is. All right. Then also create variables for the number of months, days, hours, minutes, and seconds old you are. All right. And a reminder here is remember that 5 divide 2 is equal to 2. And 5 mod 2 is equal to 1. So the way you do division, integer division in Python is with 2 slashes. Because 5 divided by 2 is equal to 2.5. And that's not what we want here, right? Since we're whittling it down from a number, from years into some other things. Let's see, how did I write this? Also creates variables for the number of months, days, hours, minutes, seconds, old you are. So, you know, when you have years, it's, I guess you could read this a couple different ways. Probably the way I meant to intend this is to give me like the most accurate version of your, yeah, of like your how many years old you are, maybe off your birthday. But the way this probably should be done is for your practice is for you to say, here's the number of years, have a variable for months and have it be the equivalent to that number of years. If you were 1 year old, you would also be 12 months old. And then the number of days, the number of hours, minutes, so on and so forth. So with that in mind, you won't actually need this stuff for solving it. All right, questions, comments, concerns, bribes? Due Tuesday or Thursday. Yeah, almost every assignment I give, it's due the next class, unless I specify otherwise. Okay, and to submit it, submit the self-evaluation, which is linked on Blackboard over on the left-hand side, and also a screenshot of your code. Your code will be short enough. You can just give me a screenshot of it. So I see that you did it inside of Linux. So you'll have to look up, how do I do a screenshot in Linux? Okay, so upload an image and upload your self-evaluation. Yep.
So the third entity or whatever parameter within that range, is that the one where we would specify if we wanted to go up to or down to?
Correct. Yep. It's the step.
Plus or just no negative sign?
No negative sign like that. If you wanted to go up by 2.
Yeah.
So 10 to 100 by 2s. 94, 96, 98.
All right.
Okay, I'll see everybody on Thursday, and I'll put this up on Blackboard right now. Anybody online have any questions?